In this video, we want to find the sum from I equals 1 to k of I times 3 to the I power. So let's call S the sum of this, and let's write out a couple terms. So when I is 1, we have 3. When I is 2, we have 2 times 3 squared. And then we have I equals 3 is 3 times 3 cubed, all the way up to k times 3 to the k. So the way we're going to solve this is by trying to eliminate most of these terms, or at least get them into a geometric series so that we can find the sum easily. So the way to do this is, first notice that every term I'm multiplying by a factor of 3. So like here we have 3 to the first, 3 squared, 3 cubed, 3 to the fourth. So that's going up by a factor of 3. And so the number in front of it is like 1, 2, 3, 4. So the goal is, can we get that to be level? So like instead of going up by 1, can we level it? And the way we're going to do that is by multiplying this by 3, or both sides by 3, to get 3 squared plus 2 times 3 cubed plus 3 times 3 to the fourth, all the way up to k times 3 to k plus 1. And now I want to focus on this. So the second term with the first term, third term with the second, fourth with the third, etc. Okay, so the only difference here is, like, this is 2 times 3 squared, this is 1 times 3 squared. This is 3 times 3 cubed, this is 2 times 3 cubed. So the number in front, the coefficient, is 1 more than the bottom one here. So when I subtract these, we have s minus 3s is negative 2s. This one is over here, and so then we focus on the other one. So we have 2 times 3 squared minus 3 squared is just 3 squared. 3 times 3 cubed minus 2 times 3 cubed is 3 cubed, etc. And then when we get to here, so this term should have been k minus 1 times 3 to the k. And here we have k times 3 to the k. So the 3 to the k's are the same. So you just do k minus quantity k minus 1, which is just going to give you 1. And then you just have a factor of 3 to the k. And then finally, this term right here is by itself. It doesn't go with anything, so we subtract that term. So now this is a geometric series with r being 3. So we can find the sum. Basically, the sum is going to be the first term minus the omitted term. And what I mean by omitted is the term that comes after the last term. And then over 1 minus the ratio. So in this case, the first term is obviously 3. The omitted term is the term that comes after 3 to the k. So what comes after 3 to the k is 3 to the k plus 1. And then that's going to be 1 minus over 1 minus 3, which 3 is the ratio. So 1 minus 3 is negative 2. And then at this point, I can rewrite this as negative, and then 3 to the k plus 1 plus 3, which, if you factor out the negative, you have 3 to the k plus 1 minus 3. And then we have a negative 2 on the bottom, so the two negatives are going to cancel. And we have 3 to the k plus 1 minus 3 over 2. Now we need to solve for s, so we can divide both sides by negative 2. And this now becomes a positive, so positive k times 3 to the k plus 1 over 2. But then the first term is negative. I can bring these two fractions under 1. So we get a common denominator by multiplying the second fraction by 2 over 2. Bring it together, factor out a 3 to the k plus 1. So we have 3 to the k plus 1 times a quantity 2k minus 1, and then plus 3 all over 4. And that is the sum.